Okay, hello everyone. It is my greatest pleasure to introduce my NIST colleague, Bill Newhouse. It's great to have Bill to tell us the work of National Cybersecurity Center of Excellence. It's NCCOE as in the front page of this talk about the migration to post-quantum cryptography project. We all know that NIST is only the first step. We have a huge challenge to deal with the migration. So we already start in the NCCOE, and today let's hear what Bill will tell us. Now, please, Bill.
Thanks, Lily. And note, Lily, that the second slide I'll show will lead us to your boss, Matt, and his recent video that he made on this topic. So just to give everybody a little sneak preview and give you a chance, Lily, to say, oh, don't do that, Bill. I'm kidding. It's a good video, and it was made public in our blog. Thanks for having me, ATARC. Thanks for the invite. My colleague, Daniel Elliott, is in the participants list. He's our outreach and engagement lead for this project. We'll describe this project. I expect Kurt Barker, who I consider one of my our subject matter experts on the project, and actually Lily's name is listed as one of the subject matter experts because migrating to post-quantum cryptography relies on people who know more about cryptography than I do to cover all the facets and the challenges here. So at the center, I wish we were just called the Applied Cybersecurity Center because we have this grandiose name, but it was given to us by the people who gave us the funding. So you're welcome for that. And don't hesitate to ask questions in the chat as we move forward. I don't mind being taken down a different cul-de-sac if necessary. I mentioned I'm gonna show Lily's boss, Matt Scholl. We have a NIST cybersecurity and privacy blog, and Matt created a video that I'm gonna switch to now and share just to kind of give a frame the conversation today. The invite you got for this meeting said something big about NIST and post-quantum cryptography. This is a project that helps organizations, what I'm going to talk about today, organize and get ready for the work that Lily and her colleague, Dustin Moody, and others are working with industry and academia and lots of people to pick the next set of algorithms that can be that will be post-quantum ready and resistant to the challenges of quantum computing. So we're the prep team, we're the Y2K and actually the Y2Q. I met the guy today who told me he first put that in a tweet in 2015. So we're getting ready for the need to prepare yourself to deal with the risk that quantum computing will put against our public key cryptography infrastructure. So I said I'm going to show you a video. Here it comes. Right, I have to switch to a browser and hit play.
Here we go again.
Wait a minute. What is this quantum thing? Is this Y2K all over again?
I hope my files are safe.
My stuff, my
Passwords,
My personal info.
my emails, my texts.
my photos, all of my messages, my data.
Not another upgrade.
How much is this going to cost?
Quantum.
Quantum.
Quantum?
Quantum.
Relax. We know. Once access to practical quantum computers becomes available, all current public key algorithms and associated protocols will be vulnerable, potentially exposing your encrypted information to criminals, competitors, and other adversaries. Yes, your texts, emails, credit card payment information, digital signatures, online transactions, sensitive data, and intelligence and government classified secrets will be in jeopardy. But no, this is no Y2K event or a doomsday scenario. All your keys won't turn to dust. And a quantum computer capable of doing this is still many years, if not decades away. It's no time to panic. It's time to plan wisely. For over 50 years, NIST has set the standards in cryptography, from DES to triple DES to AES, and post-quantum encryption will be the same. We are working with the brightest minds in government, academia, and industry from around the world to develop a new set of encryption standards that will work with our current classical computers while being resistant to the quantum machines of the future. These new standards will be released in 2024. So what should you do in the meantime? First, keep encrypting as you have done all these years. Second, follow our work and start thinking about what software and hardware you will need to replace once these new standards are out. Now take a breath. And know that we are staying ahead of this new potential cybersecurity threat. Together, we will be ready.
Alrighty.
I feel a sudden sense of calm and peacefulness.
Perfect. That's exactly the outcome. All right, I'm done then. No, I'm kidding. Let me find the share again to get back to the slide deck. And the right screen on the slide deck. Oh, I don't want to share screen. Let me cancel this fun stuff. Yeah, so that's the framing that I hope is not too surprising. Let me the share so I can get the right one. Is anybody, not in this space who's on this working group? I doubt it, right? This is a problem you guys wish you had people make videos for, and Lily brought you one because Lily, you can describe your role in Matt's creation of this, but we're using our blog and our voice, and now we're using our efforts to do the work her team's doing and to talk about this preparation part. So back to sharing let me get rid of the browser just so I don't mess it up again. All right, screen 2, PowerPoint slide. So I assume now you're just seeing Matt on a slide, and if I change the slide, it's on to the next slide, true, false?
Yes, you're good.
Okay, I never want to be the guy showing you the little slide on my next slide. So
you're totally good, it's all good.
So now too many words, but as you're aware, there is work going on that Lily's team is doing. And if you want to know more about that, I won't be speaking to it. It's not my place. I could occasionally say, oh, I heard Dustin Moody on her team say something, but it's really better that she would do that for this group. But if you're not in that forum and you're interested in becoming more knowledgeable about cryptography and algorithms, it's a fantastic place to kind of dive in and everything goes over my head personally, but it's a neat opportunity and a brave thing to have done to allow people to sort of throw their ideas in there and then see how people react to them. So the forum exists, and that's happening in the Computer Security Division. I'm in the Applied Cybersecurity Division, and I'm at the National Cybersecurity Center of Excellence, where we have applied cryptography projects underway, and these are 3 of them. I'm going to talk about the one on the left side of the screen, migration to post-quantum cryptography. Make sure I'm also looking at the chat in case somebody says something crazy. If a company has created a working quantum process for encryption that works on classical digital systems, who would they talk to at NIST for said? That, Lily, I put you under the bus for that one. I think it would be go to her forum and engage there. At the same time, yeah, no, because frankly, we wish to work within standardized processes. So if the encryption an algorithm has been standardized through our NIST process and then goes through the draft publication process and everything, when it comes out the other end, we're going to be pointing out those algorithms and their use. So anything else needs to sort of be built into, kind of connected into that system. Lily, you want to add to the answer to that one?
Yeah, I kind of understand that the question is that you already have a kind of quantum process for encryption, right? You want this can be used in the classical computers. You want to say who you want to talk to. Is that a correct question?
Correct.
Okay, so right now, as you said, you have seen that we are in the 3rd round of this process. So we currently only consider that the algorithms already in the pool. At the very beginning, we have 82 and then narrowed down to 26, and right now is 15. And so we do not accept the new encryption algorithm at this time. But in the future, maybe we will have a unwrapped signature schemes. So that's a different question. You can go to the www.nist.gov/pqcrypto to see our procedure and to see other candidates. Thank you.
Cool, thanks, Lily. And don't hesitate to continue asking questions. And you put Microsoft question, that means you work for Microsoft. If that's true, there may be other colleagues of yours kind of already engaged in different aspects of the conversation that we could, maybe plug you into as well, recognizing that we work for a big organization, NIST, Lily and I do, and then you also work for a large company. So there's different angles to all these challenges and problems. So that's you can reach out to me at my email, and Lily's will be in the contact at the end as well. The challenge shouldn't be too surprising. We've described this. We offer the challenge in a project description. We use the project description in a public Federal Register notice to ask people to come and work with us here at the center, at this Applied Cybersecurity Center. So the offering up the space as being a challenge is part of what that video did. Then we're reliant on a lot of these things as kind of Captain Obvious to this group, but we wrote it down enough so that we could inspire people to come join us and bring us technologies. Now I'll describe in a second what we'll be looking for. And I often, when I brief this, people want to know, well, when is that quantum computer going to be available that would break our crypto? And it doesn't exist today that I'm aware of. And so and I'm not a prognosticator, but within my lifetime feels like a good answer. I'm 55 almost, and so that doesn't seem crazy, but also could mean that that's 45 years from now. It could mean it's 3 years from now. So getting ready for it is important. The bottom bullet that says adversaries are already archiving key establishment and other quantum vulnerable information means that if you're relying on these public key cryptographic systems and data is moving around, data is at motion through the networks, and somebody's able to get a hold of it, they can't see it today, but they can store it, and storage is cheaper than ever. And so this threat is, just that's a way to think about the threat as being kind of scary, because then they can come back later, once they do have a computer that lets them take advantage of this structure, then they come back and they can start looking through your messages, looking through your data, and that could be damaging to you personally, to you, to your organization, and lots of other ways I haven't thought about. But that's the scare line that I tend to throw towards people as we think about getting ready for when quantum computing exists that could break these systems. Any questions before I move forward? Okay.
Yeah, one quick question, and Bill, you may be saying this, and I apologize if I'm not covered properly, but it looks like we're using Shor's algorithm as the high water mark. But there could be degrees of quantum-like algorithmic development, even in a classical computing environment, that I think, as you're saying in the last bullet, maybe I can't defeat 100% the encryption, but there are certain states of encryption that I can defeat with certain algorithms that collectively lead to further intelligence that help me decrypt something else, if that makes sense.
I think that sounds right. I'm not trying to become an expert to know for sure how far this stuff breaks, right? That I kind of rely on folks who there are better papers on that. So amongst the things that I have as a challenge here at the center is how far I need to scare people, how much I need to teach people, including myself, that this is a problem worth tackling. And instead, I'd rather talk about, now that I believe that, because enough smart people around me said it, what do we need to do? So this kind of question that you asked is sort of that. There are other people also helping describe this challenge. So NIST doesn't have to be the only ones, right? So the Cloud Security Alliance has a quantum safe working group. You guys are a working group. There's lots of different mechanisms to get this message out. And then who are we getting the message out to is always one of those questions. Who are we communicating with when we say do something, or here's a process that can help you? And so that little bit of nuance, we also will be partnering with other agencies, are partnering in conversations, and NSA has guidance about post-quantum cryptography already on their website, which gets into some technologies and techniques of hybrid use of things that I won't need to know about, but I'm glad that they're focused on. We'll be partnering with DHS at a a level of getting this message out across their critical infrastructure communities that they talk to, and who we naturally talk to at NIST. So Jim, it's a I'm not going down that fancy baseball route of trying to break down what it means to get a key and break, archiving the key establishment processes, because you can tell I'm the generalist on it. But if this group says, hey, NIST, could you help describe that? That's a question where we can at least say no by asking a few of our own experts and other people that we're collaborating with on the project, or we can point out what's already been done and discovered. So I'm probably underserving some of the space that Lily's team did early on in this project to describe, we're doing this because these are some simple bullets. So long-winded way of saying thanks for the push, and and do keep pushing when you feel like that's a communication space that needs to grow.
Yeah, no, that was very informative. Thank you.
Cool. And actually, and Lily might laugh at this, but your name made me think you're my deputy lab chief, because he's Jim St. Pierre, and I kept reading Jim St. Clair. I'm like, why does that sound? Oh, because it's not Jim St. So welcome to the group. All right, so the status, we've already covered the first bullet that NIST is doing that work, Lily's team. But now that as we get there are some things that cryptographers and people who, more importantly, implement cryptographic algorithms know about, that key size, signature size, the handshakes, the other things that impact performance. They need to be addressed, and so we'll need to be able to help people understand how that kind of looks today a little bit, but mostly to say we have a hint that the algorithms that will be selected will work in these ways, or what can we do to help you know more about what's coming down the road. If I told you that one of the algorithms is a camper sized vehicle and the other one's a minivan and the other one's a 2-door, well, then we need to tell you what kind of driveways to build, what kind of garages you're going to have with the roads that need to support the moving that vehicle into your usage. That's not the greatest metaphor, but I wanted to show size and differences. So dealing with that detail, the idea that we need to help develop these guidance documents is what we're doing here at the project. So the question then is, from our resource point of view, how much of that do we need to do that others aren't doing? What are the answers we should start to provide, because we can start to build or look for things? I'll leave that question. Will the candidate PQC algos be compatible with AES to Lily? You can answer that in the chat if you want, Lily, if there's an easy answer. And then the idea that test and validation methods will need to be produced. We have a process right now that cryptographic algorithms for use by the federal government go through a test laboratory process where NIST is the designer of the tests and the organizer of the labs who get accredited, validated to provide to do the validation. Then we need to think about growing into that space, but that's future baseball, but it's on the list of things that this project could eventually address. Consistent with yet to be developed standards. So helping organizations that put crypto into their devices understand what it's going to take to put these in there is my simple way of saying that one. And so this project is to develop those recommended practices and demonstrate tools and processes associated with migration. And the thing that we'll really be doing here is well, not really. I'll show it because I wrote it down. Collaborate with industry. So we put out a request for people to come join us who have technologies. Well, what kind of technologies would you think we need for this? We're not looking for the cryptographic algorithms because you don't know the standard that's, which ones are being selected yet. But we're looking for people who can help us with technologies and tools that discover where public key cryptography is being used in TLS, inside of the devices that you're procuring, the network devices, the computers, the hardware, the networking things, so we can help identify where you have potentially the vulnerable encryption being used, and then that would give you the opportunity to prioritize maybe where to start this work of swapping it out when we have something to swap in there. So that discovery angle inside the operating systems, the network services, and the applications, where is public key cryptography used, is kind of the first question we're asking the people who've volunteered to come work with us. And clearly, I should say that when they come to work with us, we had put out a request for them to submit a letter of interest in an open transparent way, then we meet with each of these groups, companies, universities, whoever has a technology, and to bring them into our laboratory, we do sign cooperative research and development agreements. That's the binding thing in the collaboration. There's no money, there's no paid for your time and services. We will work with your technology. If you offer us, and we have a CRADA with you, we're allowed to bring it into our lab. We keep it in the lab. We can connect to your lab if we need to. And then we run things to demonstrate the thing we're trying to show. So if we're doing discovery, we've got to find ways to run the discovery on real networks and real cool things. Cool things, that's fancy terms, in ways that when we run it, we document it, and we show with a NIST publication what we've learned that would help you prepare yourself. So prioritization becomes a good outcome of this, and then identification ultimately comes from it. So step one is this discovery space, but there'll be other places we'll need to go. We'll need to start, as we start to learn what the algorithms are, anticipate what it takes to start to put that in place will be a later phase of the project. So I'll pause again for any immediate questions about what you're reading here. Cool. And then timelines, it's always scary to start writing them down because then you realize how fast the year moves along. And we are in the forming the team spot here, and the fancy acronym, excuse me, our Federal Register Notice, LOI, Letter of Interest, and CRADA, Cooperative Research and Development Agreement. Then once we've picked the partners and we have the CRADAs, what can we do? What can we design? Is there an architecture? Do we need to show an integration of stuff, or will we just run stuff in a laboratory environment so that we don't come out with consumer reports style answers that say this tire is better than that tire, but we come out with good recommendations to say everybody should buy this kind of tire, or run this kind of process so you can trust that your tires are functioning for you the way you need them to. Or if you didn't know where your tires are, we help you discover something about your tires so you're prepared for winter storms. Building and documenting and outreach. We're trying, this is me doing outreach, right? But then we'll have outreach when we have something to share. We'll do draft publications where we wish for comments. So we'll come back to groups like yours and say, hey, do you agree with how we described this and what we did as being, the way we described the value of it or the process that we've described, and let you argue with us or push or make it better. So NIST always relies on that awesome bit of public comment on draft documents. So any questions about the timeline and where this project looks like it might go? It's still pretty vague. I've given you a high level description. We are at the place where once we know what people can bring to us, then we get more descriptive and are able to design and build it and describe it better in another document and another presentation in the future. Okay. Short term, meet with those organizations. In fact, we had one call today. It was fabulous, with a group who submitted a letter of interest. Hardy has a technology that does the discovery thing. Those are good things for us to find, and then convince them, please continue to want to bring it to us. So they understand that once they do, where it will be, who else will be running it. We don't look for source code to do anything sort of like break it down or do any reverse engineering or any evaluation that's down at that level. We look for functionality, and if something doesn't function, we'll go back to the collaborator and say, hey, we tried something and interestingly, it didn't work here. And they might say, well, you can't turn left from that road to that road because that's against the rules. And we coded that in there. Again, metaphor of what I'm describing there, but the goal is that our partners trust that we're going to show more cybersecurity or best practices or potentially new standards as we move together in building in our lab. Other things on this slide, I told you that the DHS is a partner, other agencies as well. They've specifically got a web page on post-quantum cryptography that you could look through. And when I send out the slide deck through your organizers here, Kirsten and such, then you can click on the links. And then, always communicating, get the CRADAs, and then, build, and publish guidance. Kind of sounds pedestrian. And the fun part will be once we get the technologies in our hands and start seeing how it goes. Everybody who's a collaborator is also a potential communicator. And so, from this meeting, you might say, oh, I want to submit a letter of interest. I've got technologies, please do. We're still accepting them. And then, please let us know where else you'd like me and my crazy voice to come and share the floor with you to say what we're doing and how it makes an impact against what you're doing. And I'll do the NIST thing where I can't say, well, I'm standing next to Hugh because Hugh's the smartest guy I ever met and his product's perfect, but I can say I'm standing next to Hugh because his goals with his technology are similar to ours, and it's just nice to be here to let you know that post-quantum cryptography is a thing we all need to be focused on getting towards, and all is kind of a big all with quotes around it. And I told you I was going to give you Lily's email, so you already have her email because she's the government chair for this group. But these are the folks who are my immediate team at present. Daniel's on the call. I don't know that I looked back at the participant list to see if Kurt's here. Kurt, if you are here, you're welcome to come off mute and chime in with something I failed to say. Over.
No, I think you covered pretty much everything. We have a number of letters of interest. We're following up to see how well they match up with the material that we had in the project description, essentially in the statement of work. And we are hoping to get additional tools offered in LOIs, and look forward to any feedback you folks might want to provide.
Thanks. And the key to having subject matter experts like Kurt and Dustin and Lily, Dustin's going to be busy writing documents about those new algorithms, the new cryptographic algorithms for post-quantum cryptography. Lily's going to make sure he does that awesome. And when we need to, we'll be leveraging that cryptographic skill they have. Kurt has also got the skill of having spent the long terms watching older algorithms be put in place. The ones that you're using today, he was parts of teams that helped make happen. So that length of time it takes to do this, he brings that expertise. And we're trying to shrink that time frame in this case, if we can possibly. So I think you gave this meeting's a half hour. I've used 29 of your minutes. Any other questions? So Michael, do you plan some regular quantum algorithms threat reassessments? So that's going to be back onto Lily's team to answer the question. The threat reassessment also could happen based on the implementation of it in technology. We're not going to be there on this project anytime soon, so that won't be a space that we focus on. But as people do threat assessments against any of the algorithms, if there's something for us to learn to help people prepare for that threat and not make it an unknown threat, no longer a 0 day but a day, then we can move forward from it. So Lily, anything you want to add to that question that Michael asked?
I guess that's kind of, we watch the development and the ones in the quantum computer progress. So that's probably the good news. And for most of the people who can use the quantum computers to do a lot of things, and then it's probably the bad news for the cryptography. So we watch straight, really is to watch how good the current quantum computers are. So that's what we watch.
Cool. And Taro France, nice to see you again. We had an engagement on a similar topic space about 1.5 years ago, if I recall. And then Hugh, thank you for explaining the MSQ part. The notion that Microsoft has a quantum development kit is great, because that's something we should bring into our lab and help people. Microsoft's got more people to tell them how to use that kit, but if we can offer something to help them, even better. So, and if we can learn from it too. So there's a fair amount of, we can also focus a lot on the education part of this as we get the technology, so that we can help people prepare themselves just to use the other people, anybody's tools. Cool. And then can the healthcare sector? Yes. Absolutely, Jim. Happy to come talk to other sectors. And we have leads. I'm also the finance sector lead at the center here. And that just means I'm looking for use cases that the finance sector cares about, and they care deeply about this space. And they have quantum groups that are doing things to leverage quantum computing and solve this problem too. So they're already kind of in the collaboration model. Cool. Outstanding. And I'll turn it back over to your organization to close out the meeting. Thanks.
Thank